Welcome, class. As you obviously have figured out, I am not here today to help you go over this review and preparing you for tomorrow's test. So, over the weekend, had an unexpected delivery of my baby boy. Cody came to us quite a bit early, but he's doing great, and so I'm spending some time with him. But I don't want to leave you guys stranded, so instead I've shot this video, and we will go over the review together in depth and hopefully address any questions you may have encountered while working through it over the weekend, studying and preparing for Wednesday's test. So let's go ahead and get started here. Alright, we're going to begin with question 1. Now, we're going to look for clues in the problems that may guide us on what we need to do here. So, starting with, find the domain and range. Alright, so we need to remember, domain is all the possible x's. Range is always all the possible y's. Okay, determine whether a relation is a function or not. So, start with our x's. We got, remember, x's are the first number in each ordered pair. So, and we usually list them in order from least to greatest. So we got -6, -2. You might cross them out after you use them up, so you don't accidentally try to use them twice. 0 and 2. So that covers all of our domain values. So that leaves the y's for the range, again, least to greatest. So let's look here, we got -5, -3, 5, -6. So I'm going to start with -6, -5, -3, and then 5. Alright, so that covers our domain and range. Now, don't forget this little part right here. Is it a function or not? So recall from our notes that it's only a function if x's are used only one time, because each x has to have its own unique y value, right, to be a function. So look for repeating x's. Well, you got -2, 0, 2, and -6. None of those x's repeated, so then yes, this one is a function. Okay? Alright. Number 2. For h of x equals 6x plus 3, what is the value of h of 1/2? Now guys, we talked about whatever is in this parentheses, that is replacing x, right? It's going to replace x in our equation. So here the equation was 6x plus 3. So we're going to write down, instead of x, we're going to put 1/2. So 6 times 1/2 plus 3. Now as always, follow your PEMDAS. So we multiply before we add. 6 times 1/2. 6 times 1 divided by 2. So that's going to make 3. And then 3 plus 3 gives us 6. Alright, so our 6 times 1 divided by 2 gives you 3, then add 3 to that. Alright, so on the next one, they want to find the value of h of 10. So now, instead of putting 1/2 in place of the x, we're going to put 10 in place of the x. And so, same equation. So 6 times 10 plus 3. Alright, and so we work that out. 6 times 10 is 60, plus 3 is 63. If you would like, I can write those down here so you can see exactly where I got these numbers from when you're studying it. Okay, so here's that one there. Alright, so that's all there is to function notation. Just recall you're replacing what's in the parentheses, where the x is, in your original equation, and then solving it using PEMDAS. Alright, a little bit more complicated one here. Same concept, right? Still function notation. You got g of x. Here they got g of -4. So we're going to replace x with -4, and we're going to solve it. Okay? So I'm going to, not a lot of room here. Now remember, when you put this in for x, put a parentheses around it. So that way when you square it, it actually does -4 times -4, rather than just 4 times 4 and puts a negative sign on it. So it's very important you put that parentheses around that -4 there, or your calculator will mislead you and give you a different answer. Same thing with this x. If you put this x in parentheses as -4, and the calculator knows you're trying to do a -4 times a -4 rather than a -4 minus another 4. So that parentheses tells the calculator that is multiplication, not subtraction. Alright, and so now you're working to solve it. PEMDAS says start with your exponents first, So we're going to square negative 4, giving us 16. Then we do multiplication next. So negative 4 times negative 4. So that will be positive 16. And then finally, we're going to do our addition. So we got 16 plus 16 is 32, plus 7 more, giving us a grand total of 39. Okay? So g of negative 4 is equal to 39. Alright, we're going to do it one more time here, this time with 2. So we got 2 squared minus 4 times 2 plus 7. Alright, so again we start by squaring the 2. That gives us 4. And then negative 4 times 2 is negative 8 plus 7. So now we do our subtraction and addition from left to right. 4 take away 8 is negative 4 plus 7 more takes us to positive 3. So g of 2 is equal to positive 3. Okay? Alright. Going on to question number 4. Let me move this up a little bit. Alright, on question 4, determine whether the following maps represent a function or not. So again, our key is there repeating x's. If we see a repeating x, does it have a different y value? If they have different y values, then it's not a function. As long as it's the same y value, that's okay. You can repeat x's if it has the same y value. So when the same x has 2 different y values, then it's a problem. So look in this first circle. I'd start by looking at the arrows. So the arrows look like single arrows. So we're off to a good start. I don't see any double arrows off of any of these x values. Remember, x on the left, y on the right, just in case you forget that. But notice here, look, you got negative 3, then 9, then 6, then 9. Interesting. So they actually do use an x twice. They use it as a 9 here, they use it as a 9 here. So even though there's not a double arrow coming off this 9, you do have a 9 here that's going to 0, and here you got a 9 going to 4. So that's not good. You can't have 2 of the same x's but with different y values. So guys, a is not a function. It breaks the rules. Now that's not really a traditional way to do a mapping diagram. We don't normally write the same number twice in the oval. It's usually just written once and has the double arrow coming off of it. But maybe they're just trying to be ultra tricky there. Just putting in a little trap, so just kind of watch out for that, okay? Alright, let's look at more traditional mapping diagram here. Alright, so you can see the x's. Each of them are different, right? So 5, 3, negative 2, 7. Each x only has one arrow coming from it. So yes, this one is a function. It follows the rules. Okay, C. You got 4, 7, 1, 3. 4, 7, and 3 each have one arrow, but the number 1 has 2 arrows going to 2 different numbers. So because of that, he breaks the rules. That's usually what it looks like when they break the rules. And so that one is not a function. Alright, then finally D. 5 goes to 3, 8 goes to 9, 5 goes to 6, 0 goes to 6. Yeah, they kind of try to do it again here, right? There's that 5 showing up twice, going to 2 different numbers. Yeah, not really a traditional way of writing a mapping diagram, but if you were to see this, understand it does not follow the rules of a function. So we're going to say nope, not a function. It's breaking the rules. So only one that's yes is B. Alright, very similar on the next set of questions. We're looking at number 5 here, which graph below are functions and which ones are not. So with graphs, the easiest way to tell is to look for that vertical line test, right? Hold your pen vertically, slide it across the graph. At each point, as long as it only hits once, you're in great shape. So this one I would say is a function. It does not hit twice on your pen at any point. Okay, let's try it with the next one. Looks good, looks good, looks good, looks good. Whoa, look right there. Alright, got 2 points on one line, breaking the rules. Can't do that. So nope, you're not a function. Okay, look at C, see? You got it right there, boom, right off the bat. Not a function, breaking the rules. D, you're okay there. Nope, breaks the rules there. No good there. So the only one that was a function was graph A. The rest broke the rules because they had that double point. If you can see that red, got that double point going through right there on that vertical line. Alright, one more thing I want to point out about these graphs. Actually, we'll get to that here in just a minute. Let's go to number 6 here. State the domain. So domain, x's, and range, y's, of each graph above. Now, you can just simply make a list because they're just individual points. We are going to assume that these are counting by ones on each of these graphs, that they're not trying to trick us there. So if we did graph A, so we got graph A, B, C, and D. Alright, so for graph A, the domain, you're just going to list all the x values for each of these points. So if this is 0, that's -1, -2, -3. So it looks like it hits every single line. So we're going to have -3, -2, -1, 0, and even 1, 2, and 3 each all have a point on them. So 1, 2, 3. Okay? And then for the range, you do the same thing. You just make a list of the y values. So it looks like it doesn't use +3 up here, but there is a +2, +1, 0, -1, -2, doesn't use -3. So don't have to repeat them, even though some of these are used twice. Do not have to repeat them. Again, least to greatest. So -2, 1, 0, 1, 2. Excuse me. Okay, so you get the idea. So B and C and D are going to work the same way. You're going to make a list of what your domains and ranges are. So what each of the x values are, what each of the y values are. Doing it from least to greatest. Don't need to repeat any of them. Just write them the one time they show up. Okay. All of these graphs pretty well share the same thing. B, you can see, doesn't have anything on -3. Doesn't have anything for +3. So that what makes it a little different than the last one. For the range, it also doesn't use +3. Doesn't even use +2. Doesn't use -3 either. So it starts at -2, -1, 0, 1. And that's it. That's as far as that one goes on the range. Doesn't go any higher than that. Alright, but you notice because these are separate points, I'm just making a list. I'm not using any inequality arrows here for domain range. It's just a list of values. Alright, so you can do the same thing with C and D. Just list what x values there are for the domain. It wouldn't use 3 or -3. Then do the, or I'm sorry, that's for the range. For the domain, it doesn't use -3. It does use all the rest. Alright, and the domain doesn't use +3 or -3. And then domain over here doesn't use -3 or +3. And also doesn't do it for the range either. So you can see that for that one as well. Alright, for time's sake, though, I want to go ahead and go down here to question 7. Oh, I do apologize. I really thought I had that up high enough y'all could see that. So I'm going to leave that up for just a moment. Let some of y'all that are writing this down do a little catching up. Do apologize for that. While you guys are writing that down, let me kind of talk about question 7 here. So just again to catch you up, since I didn't have this on the screen, all we did is list out the x and y values that were appropriate based on these individual points here, domain being the x's, range being the y's. And you can do the same for the graph C and D. I just didn't write those down. Okay? Alright, so now question 7. Determine whether the graphs above represent discrete or continuous. Now we've mentioned these words before, but we have not spent a whole lot of time on them. The basic thing I need you to remember about these two words, it's only discrete if the graph is not connected. Okay, so for this one, if the graph is not connected, okay, talking about the graph here, so like on these graphs up here, they're not connected, the points are not connected, it's discrete. Okay, if the points are connected, then it's continuous. Okay, so looking back at these graphs, you can see how these points are not connected. They don't make a single line. They're all individual, standalone points. So that is an example of discrete. Okay, so for number 7, the answer is discrete. All 4 graphs are representing discrete graphs. Okay, but I'll show you here in a moment one that's continuous, where the points are actually connected. So these are discrete graphs because all the points are disconnected. Okay, so you got disconnected versus connected. Actually, that's a great way to remember that. Disconnected, connected. Great way to study that. Alright, so disconnected graphs, discrete, connected graphs are continuous. Okay, so look right there before I even scroll up. Question 10. See? Those are all connected, right? It's all connected through here. Those are not broken up individual points. So that's a continuous graph right there. Alright, so we'll come back to that in just a minute. I don't want to skip too far ahead here. Let's go to problem number 8. Given the following table, what is the value of f of 0? F of 0, there's that function notation again. So again, what number is in the parentheses is your x. So here's my x, right? I'm looking, where is it 0? It's 0 right here. What is the y value? The y value is equal to 4. Then for the next one, f of negative 2. F of negative 2, x is negative 2 right here. The y value also just happens to be negative 2. That's just a coincidence. Alright, but just so happens the y value is negative 2 when x is negative 2. Alright, that's all you got to do for those. Alright, number 9, find the domain and range. So we got to find both for the relation graphed below. So first off, does the graph below represent a function? Alright, I'm going to move this up a little bit. Okay, so take your pencil, slide it across. Yep, it follows the rules of a function. It doesn't break the vertical line rule. So yes, it is. In fact, you might recognize this function. We talked about this one several times. This is that exponential function, right? Keep in mind with exponential functions, the graph doesn't actually reach this line. It just looks like it. It gets super, super close, keeps getting closer, never actually touches the x-axis. Alright, so it just gets close. Up here, it's going to keep going upward and outward for this part, so up and outward for that. So the question is the graph discrete or continuous? So what do you guys think? Alright, that's correct if you say continuous. Notice they are not individual broken up points. These are all one solid line. So that is continuous. It does have nothing, however, to do with these arrow tips. Arrow tips have nothing to do with discrete or continuous. It's just looking at the graph itself. Are these connected? Yes, they are. It's one solid, smooth line. They're not individual points. Okay? Alright, moving on. Let's come down here to number 10. I'll give it a second for the camera to catch up. Alright, so on question 10, we're asked to find the domain and the range of the graph below. Okay, actually on the last graph I never did that. Well, let's just back that up a little bit there. Alright, so I almost forgot the original question. So I'm going to come out here to the side, do D and R. Okay, remember with domain, it's how far left and right. How far left and right for domain. Well, see the arrow tip? That tells me that's going to keep going to the left. This arrow tip up here slowly creeps out to the right. So it's going left, it's going right. Graph's never going to end. It's going to keep on going left, keep on going right. So for the domain, that's our all real numbers. Okay, so for the exponential function, that domain is all real numbers. Now for the range, it's a different story. This graph will never cross or reach the x-axis, meaning that the y value of 0 will never be reached. It'll get closer and closer and closer, but it's never going to hit 0. However, the graph does go up. It's going to keep going up forever and ever. So since it's going to keep going up, but can't go below 0, we say y is greater than 0. Or it doesn't actually reach it, it just keeps getting closer and closer. Okay? Alright, so now that we've caught that up, we're going to move down to the number 10 here. Same set of questions, just different graph. So we're going to find its domain and range. Maybe I should do that first so I don't forget about it. So let's come out here and do that. For the domain, it looks like it goes as far left as -1. As far right as +7. Okay, so from -1 to 7. Remember, always put the lowest number first, x in the middle, 7 on the right. Arrows should always point which way? That's right, to the left. Arrows should point to the left. Okay, now the last thing you want to look at is hollow versus solid. Hollow no equal sign. Solid, equal sign. So we get an equal sign over here. Now, we're going to do the range next. So that's going to be low and high. Don't get stuck on the endpoints. If the endpoints are not the low and the high, don't use those. Look for the low and high point. So here we got a low point at -1. We got a high point up here, it looks like 6. Okay, so -1 to 6. Notice it does reach it on both sides. So we're going to put the lowest number first, y in the middle, 6 on the end. Arrows always go to the left because it's in between the box, right? And since it reaches both of those, they both get an equal to bar. Alright. Now, does the graph below represent a function? Well, do your vertical line test. Looks good, looks good, looks good. Yep, only hit once. Alright, so good. It's great. Okay, so yes. Alright, now is the data represented below discrete or continuous? Alright, so which one? Notice it's connected, right? It's all solid. There's no broken up points here. So that is continuous. Again, nothing to do with arrowheads. Don't care about what's on the ends. Just look at what's in the middle. It's all solid, so it's continuous. Alright, you got a few more function notation ones here. Keep in mind what's in the parentheses is x. So when x is 3, here's where x is 3. Follow it back over. Looks like y is 2. When x is 2, boom, go down, come back over. Y is -1. When x is 7, boom, follow it over. Looks like x is 4. Or y, sorry. Y is 4. When x is 0, come up here, hit the graph, boom. Looks like y is 2. So x is 0, y is 2. Alright, so that's that simple. Just find where it x's those numbers and read off the y value at those places on the graph. Alright, that's the expectations for that problem. Hopefully things are going well so far. Just got a couple more questions to cover here. By the way, if there's something you missed on this, I will have the video posted. Hopefully to my YouTube channel and to Google Classrooms is my goal, so that you can go back and watch this again if you need to. Alright, so number 15, find the domain and the range. So, real familiar, right? And does it represent a function? And is it discrete or continuous? So same set of questions, just different graph. So domain range. Domain, left to right. So this thing goes to -1. Over here to +6. So again, lowest number first, x in the middle, highest number on the end. Arrows will go to the left. Got a solid over here on the -1, hollow in the 6. So we get an equal to bar there. For the range, we're going to look at the lowest part of the graph, which happens to be -1, and the highest. So that's not the highest. This will be the highest over here, which is at 5. So our range is going to go from -1 to 5. Put y in the middle. Arrows to the left. Solid dot here on the 5. Graph reaches all the way down here to the -1. So these both get equal bars. Okay, so there's my domain range. Now, is it a function? Well, check the vertical line test. Yep, looks great. So yes, it is a function. Finally, discrete or continuous. Notice they're not individual points like that other one was. These are connected. It's all one solid line. So that is continuous. Okay. Alright, now we got two more little function notation questions down here. What's the value of f of 3? Again, x is what's in the parentheses. So here's 3, comes down, hits at y equals -1. When f is 1, so I'm sorry, f of 1, so when x is 1, boom, it's right there on the graph already. You didn't have to go up or down. So when x is 1, y value is 0. Alright, so it takes care of that. Okay? Alright, one last one where we're going to do those series of questions. One more graph here. As you probably figured out, this is the majority of the test. So find the domain range. Is it a function? Is it discrete or continuous? So domain, going to go to the left. This one's a little hard to read. Graph's a little fuzzy, but probably can figure it out. That one's at -5. That one's at +3. -5, x in the middle, +3 on the end. Arrows to the left. And one more time, notice the solid point at -5, the hollow point at 3. So we get a line under the -5, no line under the 3. Alright, finally for the range, we're going to look for the highest part of the graph and the lowest part of the graph. So lowest is at -1, highest was at 2. Notice it does reach the 2. Also notice on the -1 you got a solid and a hollow. Solid always wins out. So they're both going to get equal 2 bars. So we're going to do -1 first because it's smaller. 2 on the end. Y in the middle. Arrows to the left. Both of them get equal 2 bars. Okay? Alright. And then is it a function? Sure. Passes that vertical line test. So yes, it is a function. Continuous or discrete. Alright, once again, not individual points. It's just one smooth solid line. So it is continuous. It has to be broken up individual points to be discrete. Alright, that concludes that page of the review. Final questions. Okay, so we're going to start here with number 19. Alright, one last time. Finding the domain range. Is it a function or not? Discrete or continuous? We really want to drill this home, how to do this. So domain, look, there's your left number, -3. Okay. Oh, look, arrowhead. Watch out. So this one does not stop at 9. Don't draw a line at 9. That arrowhead's going to keep on going. Alright, on past the graph. So this graph's domain starts at -3 and goes everywhere to the right. So if it's to the right, that's greater than. So we say x is greater than -3. Okay, now solid dot, so it gets an equal 2 bar. Okay. Now the range. Well, this graph has a high spot right here, but no low spot because it's going to keep going down, right? So the high spot there was at 2, and it's going to keep going below 2, everything below 2. So we're going to say y is everything less than or equal to 2. It's equal to because it's a solid dot, so it's everything below and equal to it. Alright, now, is it a function? Sure. It passes the vertical line test, right? Didn't break any rules, so yes. And discrete or continuous? Once again, no individual broken up points. Everything's nice solid line, so that is continuous. Arrowhead doesn't matter. Just looking at the line itself. Alright, finally we're going to simplify this expression, the two expressions here. So guys, when we simplify, remember you're only doing two things: distributive property, combining like terms. So if we start by distributing the -3 and the +4 and the negative sign, then we can do our combining like terms. So -3 times 2x, -6x. -3 times -7, +21. Don't forget, the -3 gets distributed to both parts. Now do the 4. 4 times 6x. 4 times 2. Negative times 4x. Now if it helps, put that 1 there. Remember, if there's no number there, put a 1 there. So that's -1 times 4x. -4x. And -1 times 10. Don't forget, the negative gets distributed to both numbers, not just the first one. So both numbers, so that's now -10. Now the final step is combining like terms. So we've got a few like terms here. We've got -6x, +24x, and -4x. So combining all those, you got -6 plus 24 is 18. 18 take away 4 is 14. So there we got 14x. Now in the constants, you got 21 plus 8, take away 10. 21 plus 8, 29. 29, take away 10, 19. Okay? Alright, so that's it. Distributive property, combining like terms, you're done. Let's try one more time. 3 times 2x, 3 times 5, negative 1, put that 1 in there, times 2x and times 24, positive 1, there's no number so I can put a 1 there, times 7x times negative 5. So 3 times 2x is 6x, 3 times 5 is 15, negative 1 times 2x, negative 2x, negative 1 times 24, minus 24. Positive 1 times 7x, positive 7x, positive 1 times negative 5, negative 5. Okay, use your calculator to help you with some of that if you need to, if you have trouble with the signs. Alright, so now we combine our like terms. So we got 6x minus 2x plus 7x. So 6 take away 2 is 4, 4 plus 7 makes 11. So grand total 11 x's. Now we do the constants. 15 take away 24 is negative 9. Negative 9 take away 5 more is negative 14. So you wind up with an answer of 11x take away 14. Alright, I'm going to move that up a little bit. If you're still writing, it's not going to go off your screen. Okay, and so now we're on 21. The length and width of a rectangle. Better start drawing. As soon as I see that geometric shape, I start drawing. So we got a rectangle. Length and width are represented by 5x minus 2 and 3x plus 7 respectively. You see that word respectively just means in that order. So length is 5x minus 2 and width is 3x plus 7. Question asks to find the expression that represents the perimeter. So we got to find something to represent the perimeter. So remember guys, perimeter goes all the way around, not just halfway, all the way around, back to where you started. So if it helps, go ahead and fill in what these other two sides are. Since we know the top is 5x minus 2, the bottom is 5x minus 2. Since the right is 3x plus 7, the left is 3x plus 7. So we're going to add all the way around. Now some of you guys like to use the shortcut and just do 2 times the top and 2 times the side and then add them together. If you're comfortable with that, that's fine. If you're not, don't try it. Just simply write it all down. 5x minus 2 plus 3x plus 7. Don't stop. Keep going all the way around. Plus 5x minus 2 plus 3x plus 7. Now it's just a matter of combining like terms. So we add 5x plus 3x plus 5 more x's plus 3 more x's for a grand total of 16 x's. And then you have a minus 2 plus 7, so that's 5. And then 5 take away 2, that's 3. And then 3 plus 7 makes 10. So we're just adding left to right, adding the constants together. So you wind up with 10. And so your perimeter expression is that simplified expression, 16x plus 10. Okay, so add all 4 sides, combine like terms, and you're done on a perimeter problem like that. Alright, finally, last one. It's wanting us to do the same thing, right? Here's find the length and the width of the rectangle represented by 10x plus 4, 3x minus 5 respectively. Find an expression to represent the perimeter. So same type of problem. Draw your rectangle. You got 10x plus 4. You got 3x minus 5. Continue it all the way around because you're going to do the perimeter all the way around, not just halfway. Alright, add all your sides together. So 10x plus 4 plus 3x minus 5 plus 10x plus 4 plus 3x minus 5. Make sure all the sides are accounted for. Alright, so now we're going to add our like terms together. So we got 10x, 3x, 10x, 3x. So that makes our grand total of 26 x's. Now we're going to add our constants. 4, take away 5, negative 1. Negative 1 plus 4, 3. 3 take away 5, minus 2. Alright, so there's my simplified expression for this problem. Okay, so all we did is drew a picture. Keep in mind what perimeter is, adding all sides together. So we did that. We added all the sides together, combined our like terms, and got our final result of 26x minus 2. Alright, ladies and gentlemen, that does conclude this review. So tonight, your goal is to go home and study as much as possible before you take your test tomorrow. I will not be there tomorrow as well, so you will be taking the test without me there. There will be somebody in there to help administer the test to you guys. Do the best you can. I wish you the best of luck, and I will give you the results back on the following day. Have a wonderful day.